Part A. Express 2x minus 1 over x minus 1, 2x minus 3 in partial fractions. So I'm first going to write that as A over x minus 1 plus b over 2x minus 3. I'm then going to cross multiply to get a common denominator. So this gets multiplied by 2x minus 3. And the b gets multiplied by x minus 1. I can now take my numerator and make it equal to the 2x minus 1. Right, let's let x equal 1. So this term here will disappear and I'll be able to work out what a is easily. So left hand side, 2 times 1 minus 1 is 1. And the right hand side, I've got a times 2 times 1 minus 3 is minus 1. So therefore a has to be minus 1. Now let's work out b. So let's let x equal 3 over 2 so that this term here becomes 0. And therefore all of this will be 0. So substituting that into the left hand side, I've got 2 times 3 over 2, which is 3, minus the 1 is 2. And substituting that into the right hand side, I've got b times 3 over 2 minus 1. 3 over 2 minus 1 is a half. So therefore b has to be 4. Because 4 times a half is 2. So we have managed to figure out that in partial fractions, our original fraction is the same thing as minus 1 over x minus 1 plus 4 over 2x minus 3. Right, part B. Given that x is greater than 2, find the general solution to this differential equation. So this is a separation of variables question. And therefore, we want to collect all of the y terms together on the left-hand side. So this y is going to move down to the denominator down there. And we want to collect all the x terms together on the right-hand side. So this x is going to move up to be on the numerator there, and these two terms are going to move to be to the denominator down there. So on the left-hand side, I've just got the 1 over y dy, and on the right-hand side, I've got the 2x minus 1 that didn't move over x minus 1 2x minus 3 is on the denominator, dx. And I'm going to integrate both sides. Now, one thing you should be on the lookout for here, remember this is part B of the question, so it's going to have something to do with part A of the question. And notice that this is exactly what we had in part A of the question. Therefore, instead of trying to integrate that awkward fraction, I can replace it with its partial fractions, which was minus 1 over x minus 1 plus 4 over 2x minus 3. Right, let's integrate. So the left-hand side, 1 over y is going to integrate to be ln y. On the right-hand side, I've got minus 1 over x minus 1. So that's going to integrate to be minus ln x minus 1. Then I've got the 4, lots of ln 2x minus 3, but I need to remember to divide by 2 because of the reverse chain rule. And I shouldn't forget to include my plus c as well. So, do a little bit of simplification here. In that I'm going to rewrite the 4 divided by 2 as just 2. And what I'm also going to do, because all of these other terms here are all logarithms, I'm actually going to rewrite my constant as ln k, or ln c, or ln whatever you want really. It doesn't matter. It's a constant. I can write it as anything I want. I'm going to write it as ln k, just so it matches up with the rest of my terms that are all logarithms. Because what I'm going to do here is rewrite this to try and simplify it a little bit. So I'm going to put the positive term at the front here, and the minus ln, because I'm going to be using laws of logarithms to group these two things together, group these three terms together. To help me do that, to help me group these terms together, I'm going to take this 2, write it as a power there, so they all have the same coefficient. They've all now got a coefficient of 1, which means I can use the laws of logarithms to bring them together. So first of all, these two terms here, those two logarithms are being added, so their insides are going to be multiplied. So it'd be ln of k times 2x minus 3 squared. The third logarithm is being subtracted, so I'm going to divide by the x minus 1. And now I've got to the point where I've got ln y equals ln of all of this. I can cancel those logarithms out by doing the exponential on both sides, by doing e to the power on both sides, which would give me as my general equation y equals k 2x minus 3 all squared over x minus 1. So that's my general solution for the differential equation. Could probably have stopped at this stage here, to be honest, because part B doesn't say specifically how to write your answer. But because we had all those logarithms, I thought that I was going to need to simplify it. I'll probably simplify part C anyway, so that's why I've done all of that. Part C. Hence, find the particular solution of this differential equation that satisfies y equals 10 at x equals 2. So, x is 2, y is 10. Let's substitute that in, and hopefully, because I've already done all the hard work of rearranging, this should be pretty easy for me to work out what k is. I think if we were substituting this in at this stage, if I hadn't done that work with the logarithms previously, this would probably be a bit awkward now. So y is 10 is equal to k times 2 minus 3 all squared over 2 minus 1. 2 times 2 minus 3 is 1. 1 squared is 1. 2 minus 1 is 1. So actually, k is just 10. So my final answer for part C then is 10 lots of 2x minus 3 all squared over x minus 1. And that is in the form y equals f of x. So there we go. Like I say, technically this could have been your solution to part B of the question, and I could have stopped there for part B, but I would have had to have done all this work with the logarithms in order to have got my answer in this form anyway. So it's always a good habit to get into to simplify your solutions to differential equations.